Hi everyone, welcome to IMESH. I am Debashree Panda. I am the CEO of IMESH. Today our topic is Advanced Traffic Management with Istio, where we'll cover topics like fault injection, retries, circuit breaker, timeouts, and many more interesting concepts. Our speaker of this topic is Mohammad Ajmal. He is the founding engineer at IMESH. Now, before IMESH, Ajmal created many SaaS applications on Kubernetes in many numerous startups. So before we get started, a bit of housekeeping rules. We'll record this conversation and send you for your convenience. In case you have any questions, put them in the chat. We'll take the questions towards the end of this conversation. And if you have any questions that you feel or you find it interesting enough, then please send us at contact@imesh.ai. We'll try to answer them in a day. All right. So a bit about us. We formed IMESH in 2023. Basically, we moved out of stealth mode. We have a presence in Dover, US, and we have an office at Bangalore, India. We started IMESH with a simple mission of simplifying and securing the complicated network of microservices in the cloud and Kubernetes. As of today, we have two offerings. The first one is we provide enterprise support for open source Istio service mesh. And the second one is IMESH Istio dashboard, which is basically a visibility layer that you can plug in on the top of your Istio service mesh to get an understanding about multi-cloud network and visibility and deep visibility on service dependencies, security logs, metrics, and traces, etc. With that, I'll give right now. I will request Ajmal to take over this presentation. Ajmal, can you?
Yeah. Hello, everyone. My name is Ajmal, and I'm the founding engineer of IMESH. So we'll jump right into it. Yeah. Debashree, can you?
Yeah. I think you need to share your screen.
Okay. One minute. I hope my screen is visible.
Yes, it is.
Cool. So this is going to be our agenda today. We'll be discussing virtual service destination rules, and using these two, we'll be implementing the traffic management canary release situation. And we'll also be looking into the retries and timeouts, how you can have them. And two of the most important things that are the predecessors of testing your architecture for fault tolerant is circuit breaking and fault injection. So moving forward, we have virtual services. A virtual service is defined as a set of traffic routing rules, which we apply when a host is particularly addressed. So you can think of virtual service, it's some kind of like a routing, or you can also name it as a route manager, which will help you route your traffic. And this is the way we create virtual service is by using the CRDs provided to us by Istio. And similarly, this is the sample configuration for virtual service. We'll be coming to it. I'll quickly jump into the destination rules as well. So destination rules are the policies that are applied once the traffic routing has been done. So once your routing is done and you reach at a particular point, there the destination rule is applied. So it's very easy to visualize these two. Often these two are quite complicated in terms for people who are new to Istio. You can just think of it like if you are at a event and you want someone that, okay, hey, where do you think the lunch is happening? And the guy tells you that take the lift across the hall and go to the third floor. The job that he is doing is the job of virtual service. He's basically routing you to a particular point. Now, when you go to the third floor and you want to get into the dining hall, there is a person who is checking for your credentials. He's checking for your ID cards and invitation. And that is, you can say he's doing the job of a destination rule. Now going into the configuration, you can see the configuration itself is something that you would see in a Kubernetes description file. And the kind here is virtual service. This is the custom, you can see the CRD that is provided to us by Istio. And in metadata, what we are doing is we are basically providing the name for this virtual service. Okay. And one key thing to notice here is in the specification, you can see in host, we have the host as reviews.prod.advocacy. This is giving you the entire host name. And this is oftentimes required because there might be situations where a virtual service is being applied to a different namespace, whereas your host is sitting on a different namespace. However, if you're using the namespace in the metadata itself, you can simply go around by giving the service name in host, but it's a good practice to use the full name. And in that, we have an HTTP option. As you can see, it's a list of HTTP routes that you can provide. In this case, we are only having one routes. We are giving it the name as reviews v2 route, and it is having a few of the matchers. Now, matchers basically help you to match a specific prefix in the URI. So say, for example, if your request is coming to reviews.prod.cluster.local/WP catalog, this thing is going to be matched, or even the consumer catalog, this is going to be matched. And once it has matched, it will rewrite the URI to something like a new catalog. Basically, you can think of it like changing your entire URI when you are visiting this particular page. Now, once we are done with matching, we have a particular field called route. Now, inside route, we define our destinations. Our destination themselves are going to be different hosts. In this case, the host that we are applying the destination rule is the same as we have given at the top. But there might be situations where you'll be using a different one. And the subset is basically asking you to choose a particular destination rule. Okay. So we'll be going into that, where this subset is pointing and how it will be used. But you can also see there is a different, there is another HTTP route that is called reviews v1. And there also we have a few destination routes and rule, and you can see the matcher is missing. So it won't match for it. So these are few of the keys that you can see, few of the fields that you can fill in the configuration. You can find the entire description in the Istio documentation itself. And while we are going into the demo, I'll be showing you what all configuration I'm using. So a bit about how the virtual service works. So it's not like, say, for example, here we have defined the virtual service for reviews service only. It is going to go to that service and it will sit there. It's not the way it works. Since we know that Istio also embeds a sidecar Envoy proxy to each of your container pods. So what happens, your virtual service rule is sent to each of the Envoy proxies present in the pods. And this is done by Istio. Now, what happens is whenever your particular request is incoming, each of the Envoy proxy will check whether I should apply this virtual rule to it or not, if it is defined for a particular host or not. And that's the way it's done. It is a bit redundant, but if you see virtual services, these are quite lightweight configurations. So it's not something very intensive that you need to worry about. And this is how the Istio architecture takes it forward. Now, moving to the destination rule, you can see the configuration. It's quite similar to what we have seen in the virtual services. However, the few things you can notice here is that after we have defined the host, now this host is also important because this is saying on which host you need to apply the destination rule. On top of that, it also has few of the additional fields that you can add, such as the traffic policy. And here we are just using the default traffic policy of a load balancer. It's using a simple least request load balancer. You can use round robin and other as well, a random request and all those things. Now, this is where the subset comes into the picture. You can see we have given the subset name as test version. And if you want to use this particular destination route in any of your virtual services, you will be giving this specific name in the subset. Okay. And the labels here, please don't get confused that we are applying labels to this. This label is basically a selector. What this label will do, it will basically go and select what all the services that you have defined are having these particular labels in it. And this is where the destination route will send your request to. And obviously for each of the subsets, they have their own traffic policies and all. So the documentation will answer all your queries there. It's quite well laid out if you go and visit the Istio documentation. So, this was all about what we have seen till now. This is, we have covered virtual service and destination rules. Now we'll go into the overall concept of what circuit breaking is. So what I'll be doing, I'll be discussing the concept first, and then we'll dive into the demo. So what circuit breaking does is, now let us say if you have a particular application and it is communicating with few of the pods, and what circuit breaking will do is, so say for example, pod 1 is not performing well. This could happen for various reasons. Maybe it's the resources are lacking, maybe the network latency is quite high. So oftentimes your service, whatever API request you're trying to make, or even your gRPC calls, they will fail. So what circuit breaking does is, it will keep a record and it will see, okay, at this particular interval of time, I'm getting too many 500x errors. So I might as well stop all the request that is being transferred to pod 1. So ideally, you can say pod 1, pod 2, pod 3, these are all the same, you can say belong to the same service. And that's why the here the you can say traffic management is done, the load management policies are done in round robin fashion or anything. But if you're seeing that, okay, pod 1 is giving me a lot of 500 errors, and this is specifically this specifically works for 500 errors only, because those are the server errors that might be caused because of a pod being malfunctioning or something. It will stop transferring any request to that pod for a specified amount of time. And all these things you can define in the configuration. We'll see while we are going into the demo. So this is about circuit breaking. And there is also an option to have fault injection. So what fault injection basically allow you to do is, these all will come into the under the banner of chaos engineering. What you can do, you can specifically define rules which will say, if let us say this app is communicating to app 2, you will knowingly give a faulty response. Okay, and this response will kind of go to your app, and this is basically testing if, okay, one service is not performing well, how your system is reacting. Okay, so that is all about the fault injection. And in retries, what happens if, let us say, your request is failing, you can configure your destination rule to retry it. If it fails once, you can retry it for 2-3 times. And after that, if it's failing, you give an error message. Otherwise, if it's succeeding, then yeah, well and good, you have the app good. So in the demo, we are using a very minimal microservice application. So there are 3 services. One is the UI service. This is basically just a web client that makes API call to the other 2 services. There is a name service which will give you a list of name, and there is an animal service which will give you a list of animals. And these 2 services are being hit by the UI. And what to demonstrate the traffic management, what we have done, we have separate version for name and animal, and so that we can route traffic between these 2 versions and see for ourselves that if the demo is working properly or not, if Istio is actually implementing the traffic management or not. So this is the microservice architecture. The client UI will basically communicate with name service and animal service. And here we have only 2 pods. One pod is running the stable version of name service. Another pod is running the new version of name service. And same thing with the animal. It is running, one pod is running the stable version and one pod is running the new version. So we are using this to demonstrate, okay, if you simply run this service, few of the requests will go to stable and few of them will go to new, because that's how by default Kubernetes performs. But once we have applied the virtual route, we can basically we can restrict, or we can basically target, okay, send more requests to this particular pod, or don't send requests to this particular pod at all. That all will be seen. So this is about the microservice architecture. Now I'll be opening my terminal. So I'm using Azure AKS service for our deployment. And if I just check what all things we have. Right now, this is the namespace we'll be working on, ITM demo. You can use your own namespace and all. But this is what we'll be using for the demo. And as you can see, there are no resources in this namespace for now. And by the way, the Istio and all has already been pre-installed in this particular cluster. So if you want to know how to do that, check out our previous videos. We have a description over there. Now moving on to the what all configuration we have. We have the microservice.yaml file. This is just the YAML file that has description about what are the namespaces, what are the config map and all. Don't worry about the warnings. I have just commented out the resource limit, so that's why it's giving few a few warnings. But if I quickly go through this particular YAML file, we'll have, you can see we have the namespace here with Istio injection enabled. So so Istio knows that, okay, I need to inject my sidecar proxies here in this particular namespace. We have a config map, which is basically used to have the environment, to set the environment variable for client UI to communicate with name service and animal service. You can see I've given the particular host names here. And in the deployment, we have one name stable, which is using the stable version of name. These images are already present in the Docker Hub. Once you have the configuration file, you can use it. And the other deployment is using a names new. This is the new version. You can see this, the tag is new. And the service that we have, the name service, it is basically selecting all the apps that have the all the app that has the names. Okay, so it will be selecting both the new and the stable service, because in labels we have names for them. And this is exactly similar for the animal service as well. And yeah, we are also exposing port 80 for this service to communicate. And in animal service also, we have one stable and one new version, and a service that is basically selecting both of them. Now, when we come to the client, the specification is a bit different, as we are also having the environment variables. This is just using the config map to inject those particular environment variables, so it can be used in the client. And this service is basically using the client. So this is all about our microservice. This is nothing related. As you can see, there's nothing, no Istio related stuff other than just this label for the namespace. So let us apply this file. So I'll do kubectl apply -f microservice.yaml. It will take some time for it to apply. Yeah, we have the namespace, config map is created, deployments are done. And by the time this is happening, I'll also give you one more info that we are going to use the ingress gateway. This is not in the scope of this video, so you can probably check out our other videos where we discuss how to use the gateway. The only reason why I'm using the gateway is for us to kind of hit that client UI endpoint and see for ourselves. Because whatever virtual service rule you're going to apply, it will work for the Istio network itself. And if you're exposing a particular pod directly from Kubernetes, and it's not going through the Envoy proxy, then virtual service and the destination rules are not going to be applied, because those things are happening at the Envoy level as well, Envoy level only. It's not at your, it doesn't do anything to your application, and that is entirely separate from it. The gateway configuration is simple. I'm just defining a gateway and I'm opening port number 80 for it. And then we have just the virtual service that is defining, okay, whenever I'm visiting this route, simply pass this request to the client service, which is running at port 80. That's what we have exposed in the here, the app configuration. So we are all done here. Let's see if everything is created or not. Yeah. So as you can see, all the pods are running. We have, and one more thing, if you would have seen it saying 2.2, this is because we also have the Envoy proxy with it, which is injected by Istio. So everything is up and running. Now let's go and apply the gateway. Okay, gateway is created, virtual network is created. I should be able to go there. The IP was this. Yeah. So this is our app. You can see we are having a list of names. 3 names are coming. A list of animals. 3 animals are coming. The UID is just a random number. So whenever we refresh, we have something new to see. Okay, yeah, this changed for sure. And this version will basically tell you from which version this request was served. Right now, you can see the version is new in case of names. It means that the new version was the one that replied to a request. The request got to that new version. And for animal, it did go to the stable version. If I simply refresh the app, you can see the UID is changing. And now the request is going to the new one for animal. It's going to the stable one for name. And this is done by default. Whatever traffic routing you're seeing, it's done by Kubernetes by default, because right now we haven't applied any destination rules for it. Now moving forward, let's look at the destination virtual service and destination rule for the canary release. This so in this YAML file, I have both the virtual service and destination rule. However, you can make separate files for it. That's entirely up to you. Now, a few things in the configuration, you can see we have almost everything similar to what we have discussed in the presentation. The configuration is of kind virtual service. We have given it a name. We are also specifying a namespace to it. And the current host that this particular release will be applying is to names service ITM demo. So this is going to name service, and this is the entire host for that. And in HTTP, we have a name. I'm just giving it a name service routes. And one thing to notice here is in the route, we are having destination. So so what you will be doing for a canary release, what we usually do, we we create a new version. We create pods with new version, and we also have the pods with the older version. However, both of them are under the same service. So what you can do here, and as by you can see in this particular description, what I've done in destination, I'm giving the same host name. Okay, it means that whenever the request is coming to this route, we will be choosing this particular host, and we will be choosing the destination rule given by this particular subset names table. We'll be going to the configuration for destination rule. And one more thing that we have is the weight. Now this weight will basically tell you how much request you want to send to which particular route. Now right now I'm sending 100% of the request to this particular destination rule, that is names table, and it will go to this host, and then it will go to this particular destination rule which will be served. And there is another destination rule as well. I'm setting it to 0 for now because we want to see in action if it's actually sending all the requests to this table one and no request to the new ones. And the only difference here is that we are using the new subset here instead of using the old one. Now these two subset definition, you can find it in the destination rule. And here also we have the same kind of the structure. We have a name, which is name service dr, and we have the namespace, in which namespace I want this to be applied. And you can see in host, I'm not giving the full host name here because it is in this particular namespace only. So if you are providing the namespace, you can skip providing the entire host. But however, this is a good practice. I'm just not providing it here to showcase that even if you don't do it, it will still work. And I'm giving the traffic policy as round robin by default. This will be applied. And there are two subsets. You can see there is one subset that is having names stable, which we have referred here, and the another subset that is having names new, which we have referred the other one. So what this subset do, now the subset will decide once the request is coming to this particular destination, which pod should I send the request to? Now, if you go to the microservice, you can see there is one in the deployments. We have one for the stable, and we also have the deployments that are done for the new one. And in the labels, we have given the app and the version name as well. Now, these are the labels that is being selected in this subset. Now, again, the name is label, so please don't get confused. This basically means that we are selecting the pods wherever the app name is names and the version name is stable. So in this case, whenever you see that anything that is referring this particular subset names table, we can say that all the requests will be sent to those pods that are having the label as names and the version as stable. And whenever the request is hitting this particular destination, right now it won't because we have given the weight to 0. It will go to the names new, which will only select the pods which are having the version as new and the app name as names. And one thing to keep in mind that whenever you are looking at the version stable, it is referring to the stable image, and whenever you're referring to the version new, it's referring to the new image. So let's quickly apply this file. Kubectl apply. Istio canary. We'll wait for some time for it to apply. Yeah, it has created the virtual service, and you can also get the virtual service and destination rule by using this command. Kubectl get virtual service. Okay. I think the resource type is not applied. Let me just check the configuration. It is applied to the right one. Let's check for all. We have everything here. This looks fine. Now let's go and we hit the request. So I'm refreshing this page again. You can see we are getting the names as stable. I'll be refreshing again. And it is pointing only to the stable. You can see the animals is changing to new, but the names is remaining at stable because we are transferring 100% of the request to this particular route. For canary releases, what you can do, you can change the weight to something like 90 and 10. These should add up to 100, and you can reapply. Yeah, the virtual service is again configured. And now if you go and if you hit, in most cases, you can see we are getting stable in names. Only few times we'll be getting new. This is how you would do a canary release. You can also do A/B testing here by changing the weight to 50-50, where 50% of the traffic is routed to the stable one and the 50% is routed to the new one. So this is how you will be doing traffic management using the virtual services and destination rule. I'll quickly go over the retries as well. Since our service is not failing, we won't be able to see the retries in action. But this is the configuration for retries. For a particular virtual service, you can basically define that how many attempts you need to make and what is the timeout for the retries and when to retry. So there might be a connection failure or a gateway error in cases you want to retry, and even in refuse stream. So if I remove refuse stream from here, if your request is failing due to a refuse stream, it won't retry. It will only retry when your request is failing due to some connect failure or gateway error. So this is how you will be doing the retries, and these things are having timeouts and everything. This is being configured here. You can find everything in the documentation of Istio. They have properly laid out what all these fields are. There are a few of the more fields as well that you can use, which is beyond the scope of this demo. So we won't be going over that, but yeah, you can configure it using like this. So this is generally how you will do the traffic management. Now, what I'll be showing again is regarding what happens if you try to use circuit breaking. So right now the microservice is functioning well, so the circuit breaking won't work. So what I have done, I have created a microservice with a bad app where I've explicitly made sure that animals is having one pod that is having a bad configuration, which will fail. Basically it will give you 500x errors, and then we'll see how the circuit breaking works. So I'll be applying this file first. With bad app, the only thing changing here is I'm instead of using the animals new version, I'm going to use the animals bad version, which has bug in its code. So ideally the circuit breaking is done when you have network failures and all. It's not that your if your application is causing any issue, you should be checking it while testing. But yeah, just for the scope of demonstration, we'll be using a bad application for it. And once it is applied, I'll simply go and refresh. You can see we are getting few of the errors that is saying that this particular version is coming with bad with error. And I've programmed the app to also render when the error is there because I'm returning the same object. So that is just for our understanding so we can visualize. But yeah, you can see that it is giving you some bad error. Now what we can do is we can apply the circuit breaking rule, and circuit breaking is done by the destination rule. Okay, so here we have a destination rule which will be applied to the animal service, and here we are saying in the traffic policy this is the outlier detection. Now this is where we defined how to how the circuit breaking should work, and what all things should happen. If you can recall in the previous diagram we had seen, when the circuit breaking happens, it checks for a few of the 500x errors, right? So here we are defining the number of errors to check and at what interval of time. So here I have the consecutive 500x errors to be 3 and the interval is 30. It basically means that with it will keep checking in 20 seconds, if the number of errors is more than 3, then it will basically apply the circuit breaking policy, and it will not send any request to that particular pod. Okay. And this time you can change, you can keep it 10 seconds, 15 seconds, and you can increase the number of errors to as and how you like. For this demonstration, I'm keeping it to 3 and the interval is 30 seconds. And the base ejection time basically means that for how much time you should stop request from hitting that pod. Right now I'm keeping it 30 seconds. After 30 seconds, it will again send that. The whole point of circuit breaking is, now if you're having a particular network failure, it will basically stop the request from going there, so that that particular pod could restart depending on the policies that you have defined in your Kubernetes file, which is why this base ejection time is also one of the important factors here. And this max ejection percent is basically how many requests you want to stop there. In our case, we are basically saying that no, all the requests should stop. 100% of the requests should be ejected when it's going to that. So let's apply this as well. And one more thing you would have noticed is that this particular destination rule is not dependent on any of the virtual service. So there is if you have any confusion there that, okay, I need to use destination rules only with the virtual service, it's not like that. The destination rules and virtual service, both of them are applied at the Envoy proxy level. So in case you have a destination rule for a particular service, it will be applied even if you don't have a virtual service, because virtual service basically just guides your route. It doesn't mean that if you don't have a virtual service, the route won't be hit. So this will be applied whenever you're hitting that animal service. Okay. Now this file is applied. Now if I go to this particular server and I hit refresh, you can see we are getting few bad errors. And right now, see, I'm refreshing, I'm only getting stable. We got 2-3 bad errors in 20 seconds and now it's not happening. And this is because the circuit breaking is taking place and it has broken the circuit. I can probably show you with the Istio yearly dashboard as well. Here you can see in the last 10 seconds, we'll go to graph, choose ITM demo. You can see in last 10 seconds, we are having this particular pod, this particular animal service failing. All the red lines are going to new and only green line is going to stable, because we are only using the stable pod for it after circuit breaking. And once the 30 seconds has elapsed, it will again, kind of send request to that pod. So that is something you can, check. But yeah, this is how your particular app is functioning right now. Okay. You can also diagnose whether this particular server is malperforming by seeing how many requests it is failing. All the charts are here. So yeah, you can definitely have a look at this as well. So this basically, it's a proof that, okay, our circuit breaking is working. Now you can see after 10 seconds, all the requests are going to the animal stable. It's not showing anything, something like, animals bad or something like that. It's not showing. However, if you see for the last 10 minutes, we have the request going to every place. Right? It's also going to the new and stable. It's also going to new and stable for this one. So this is how the circuit breaking works, and so that's how you'll be applying. This is the configuration for it. And one more thing we are going to look at is the fault injection. Now, fault injection. Before I do that, I'll reset everything. So I'll be. So because we are having a lot of rules applied to a lot of different places, just so we can check this one independently, I'll be stopping that. And we will reapply the microservices, and then we'll reapply this particular rule to see if the fault injection is actually working or not. Okay. By the time it is being created, we will quickly go through the configuration. The fault injection is achieved by virtual service as opposed to circuit breaking, which was achieved by destination rules. So everything is similar. We are also having the host name. I'll be fault injecting in the name service, and whenever the fault injection is happening, whenever this request is coming to this particular route, I'll be using this HTTP rules to do it. So right now we have a name, and I'm just giving a normal name to it. To perform fault injection, there is a field called fault, and in fault you can basically say what all things you need. In this case I'm saying to abort the request and simply give an HTTP status of 504, and do this for all the 100% of requests. Now you can choose to just have faults for 20 to 30% of requests to see if how your service is performing, if there are few errors here and there. But in this case I'll be saying that no, all the requests you just give a 504, so we can actually see if the app is breaking or not. And this is applied to the destination of name service. I have not given the entire host name here because I've already defined the namespace here. Okay, I'm just mixing and matching things so you can understand. You can sometimes get away without using the entire host name, but again, reiterating, it's a good practice to use it. Cool. So we have everything. Get all ITM demo. Yeah, so we have everything. And once the request is failing, so this client app will also crash, because that's how I programmed it to be, so we can know that it's not working properly. Let's see what is the logs for this particular pod. I'll be simply storing it in temp.txt. So if I go there, now you can see in temp.txt, we simply have few basic information. It's a Node.js app. It's running here and there, and there is no error whatsoever here. And if you, yeah, I need to apply the gateway as well. Otherwise, we won't be able to reach that. Cool. So the app is working fine now, and there is no other destination rule applied, so there is no confusion. It's working as we expect it to work. Now what I'll do is I'll do the fault injection and I'll apply the fault injection configuration. So it is applied now. Now what will happen, I'll just keep this one handy. Now if I go and I refresh, it's giving me an error. I'll quickly capture it. You can see the app is failing and it is saying some reset reason, there's a connection failure, a delayed in connect error and all those things. If you go to the temp file, it didn't capture probably. Yeah, you can see the restarts count has increased. It has restarted once because it was having an issue, with it. So what we'll do, we'll try to be quick so that we can capture this error. Yeah, now you can see it's saying that this is anyways the app running thing, and now we have an Axios error. It's using Axios to make the API call, and you see the request is failing with the status code of 504. And this 504 is what we have defined in the fault injection, right? So ideally, while designing the microservice, you need to account for these failures as well. You have to test it. This is failing for now, but yeah, it should a good microservice should respond to it, and it should work properly. But now you can see the fault injection in action as well. So this is how you'll be doing it, and everything, just reiterating over it, we have seen how to apply the gateway and how to do fault injection. You've also seen how the circuit breaking works and how the canary releases work. So yeah, so this is it, and awesome. So yeah, you can, if you want to book a demo, you can contact us at IMESH@AI, and yeah, thank you.